All right, so here is number 9 on the homework, or 7.4.24T. And this is the one about the basketball players in the basketball league. So I'll just go ahead and download the data set in Excel. First step, and I'll enable editing. All right, so the first thing it wants from us is the mean and the standard deviation of the population. So this is a population, it's 60 data points, all the players in the league. So I'm going to just call this the population mean, the population standard deviation. I can do that by doing equals average, and then highlight all 60 data points in the data set. And the population standard deviation, I'm going to do equals st to ev dot p, because it's a population, and highlight all the data points in the data set. All right, so there's the first two things I need. Population mean, round to 1 decimal place, so 69.8. The population standard deviation to 2 decimal places, 44.52. So the next thing it wants from us is to do the probability of a sample mean of 45 players. And so we've got a lot of things we have to figure out to make this work, to find the probability of a certain mean of a certain sample. The first thing we need to know is how many data points are in our population. In this case, it's 60, because there's 60 total players. And then the little n, which is our sample size, and so that's going to be 45 players. And then finally, we need the sample mean that we're testing for. I'm going to call that x bar, right? The notation is like an x, a little bar over the top of it. And that'll be 69 inches for this one, part B. So now that I have all this information, I need to calculate the standard error of the mean, because I need the standard error of the mean to calculate a z-score, and then I need the z-score to calculate the probability. So I've got all these things I've got to figure out. So the standard error of the mean, there's not an Excel function to figure it out. So instead, we have to do a formula. If you forget the formula, you can always look and view an example. I'm sure you already know that, but I'll show you. Like, it'll have it. So right here, our standard error of the mean is our population standard deviation over the square root of n. And then, because in this case, our sample size is so large relative to our population size, we're also going to have to do a finite population correction factor. And so that will give us our corrected standard error of the mean. So our standard error of the mean, then uncorrected, is going to equal our population standard deviation divided by the square root of the square root of little n. There's our standard error of the mean, and then our finite population correction factor is going to be the square root of big N minus little n divided by big N, divided by big N minus 1. So our corrected standard error of the mean will be the standard error of the mean times the finite population correction factor. So now that we have our corrected standard error of the mean, we can calculate the z-score. And I'm going to call this the z of x bar, or the z-score of a sample mean of 69. So the z-score is just going to be x bar minus the population the population mean divided by our corrected standard error of the mean. So then, if we want to find the probability that z of x bar is less, so that this is less than this x bar of 69, we're just going to use norm.inv, I'm sorry, norm.s.dist. So that's the standard normal distribution. And then we put in our z-score, and for cumulative, we put true. So that's the probability that our sample mean will be less than 69, right there. That's for 4 decimal places. Sometimes I like to do that so I don't have to figure it out. 0.136. Whoops. 0.0136. There we go. The next one wants the probability the sample mean is more than 70.5. So if I put in 70.5 right here for x bar, this is going to return the probability that it's less than. So my probability that it is more will just be 1 minus the probability that it's less. 0.0136. And then finally, the probability that it's between two of them. So whenever I want to find between, I start with the highest x bar value it's looking for, which is 71. And I find the probability that it's less than that. And I'm just going to copy it, and then I'm just going to paste the value of it over here. Then I'll put in the lower value, which is 69.5. And then the probability that it's between the two of them is the probability that it's less than 71 minus the probability that it's less than 69.5. And that'll be the probability that it falls in between, which is 0.76. And that's it. So probably, I mean, what most people struggle with the most on this is that finite population correction factor. They forget to put it in there. And again, you'll know it's there whenever your little n is large relative to your big N. In other words, your sample size is large relative to your population size. And so the rule is that if, sorry, I was just double checking the book, so I didn't tell you the rule wrong. But the rule is that if big N, I'm sorry, little n divided by big N is greater than 5%, then we'll go ahead and use that finite population correction factor. So I hope that was helpful, and have a great night.